And we are live, hopefully. GM, everyone. So you should be able to hear some music. You should be able to hear me or see me at least. Let's hit some GMs into the chat. So I can confirm that you can actually hear me. And we're gonna start in a couple of minutes. So we're gonna wait for everyone to join us. And then we're gonna kick off this workshop. Fantastic, thank you. GM TP, what's up? I have no idea, literally. So this is like from the broadcast platform that we're using. They have a couple of built-in music templates, whatever. So I just hit the lo-fi. So I don't know, but I can maybe Shazam it later or Google it and post it on Twitter, and we're gonna find out eventually, hopefully. But yeah, let's start. So first, to turn off the music. It's not ChatGPT. Okay, so I'm gonna turn on the music, hide this banner. And yeah, let's start. So hello everyone, welcome to another Chainlink workshop, Chainlink Hackathon workshop. Today's topic will be integrating ChatGPT with decentralized application using Chainlink Functions. So hopefully you already know what Chainlink Functions is, but if not, we're gonna cover that as well. I assume that all of you here watching this know what ChatGPT is, obviously, if you and maybe try it and maybe have a couple of ideas how to use it in Web3 space or with blockchain technology. So this workshop is going to be all about that. I can also say that for this hackathon, for the first time, we have a separate AI track, so artificial intelligence track. So anything that use similar technologies to this one is applicable to that track as well. So if you have some ideas, make sure to apply to that track as well. And yeah, let's build. So before that, my name is, as you maybe already know, Andrei Rakic, and I'm one of the developer advocates for Chain Protocol Chain Collabs. Here you can see listed my Twitter and Lens handles. If you have some questions after this workshop, after the Q&A session, feel free to ping me there, to write a tweet on my wall. I'll make sure to answer you. Okay, so yeah, this is gonna be like a hands-on session, so you can follow along or code along with me. I'm gonna try to keep it at a reasonable pace, but for you to be able to use Chainlink Functions later, you will need to sign up for beta. So Chainlink Functions is currently still in beta. During this workshop, I'm gonna simulate the response. So we're not gonna actually deploy your smart contracts to the blockchain, but if you want to deploy it to some of the available testnets at the moment, you will need to sign up for Chainlink Functions, and you will be approved in 24 to 48 hours max, but probably under 24 hours. So if this QR code for some reason does not work, the official website is functions.chain.link. And this is like a simple type form. Tipik has a good question. If we did the masterclass yesterday, are we registered already? Yes. So if you already sign up for beta and you're whitelisted, yeah, don't need to do one more time. So how to be whitelisted? You will need to enter the address, the wallet address, basically, of your wallet account, externally owned account, and you will be able to create function subscriptions, manage them, etc. If you're not whitelisted or you're using different wallet address, you should be able to actually see inside the terminal like the error message saying hey, you're not whitelisted. This project is currently in beta, blah blah blah. So go to this URL and register. So again, I'm gonna just simulate the response, but if you want to deploy and actually use this on some of the testnets, Ethereum Sepolia and Polygon Mumbai are at the moment available, then you will need to sign up for the beta. Okay. So what is Chainlink Functions? So Chainlink Functions is basically a system to execute any code you want to run and get decentralized and verifiable consensus on the result. So you are aware that Chainlink has a system called any API or external API, whatever. And that system, like it works great, but it's not extremely suitable for production ready code. The main reason or the major reason is that if you follow along the official documentation, you will see that the like beginner friendly example actually use one single node and one single API endpoint. This means that this thing is extremely centralized, right? So for you to be able to actually properly build a production ready code, you will need to manually speed up multiple nodes and have multiple API endpoints, and then you will have like a verifiable result. Chainlink Functions take this to the next level. So let's say you have API endpoint and you want to create, for example, HTTP GET requests to that API, any API endpoint. Let's say it's like for getting a price of some assets, whatever. The request is not going to go through the node. Actually, it's going to go through the DAWN. So as you already know, or maybe you don't know, DAWN stands for Decentralized Oracle Network, and it is a network of Chainlink nodes, which basically functions separately. And this DAWN is just a decentralized Oracle network. It's not a blockchain, but it needs to reach a consensus. So that's the main reason. So how this thing works, basically, if you create an HTTP GET request, each node is going to execute the same request on in its own serverless environment, provide a callback result to the rest of the network via peer-to-peer network called OCR. Then the DAWN will reach a consensus on the final result and then send it back as a callback value to the calling smart contract, which is a purely decentralized solution and much easier for you rather than like managing multiple nodes and multiple endpoints. Okay, but besides this HTTP GET request, now you can actually write any type of code. It can be HTTP post request, like you can send emails, notifications, etc. You can perform like computation that is usually extremely expensive to be done on a blockchain or in Solidity. Like, for example, you have a DeFi project and you need to create some kind of complex math or some, I don't know, like some math computation for, I don't know, like some extreme use cases in DeFi, whatever. Like these type, like Solidity is not the best language for that. Like Solidity doesn't have decimal places. All of these computation can be extremely expensive to be done on chain. For example, I don't know, like logarithmic values, etc. So you can actually outsource or crowdsource this work to the DAWN at a fixed price as like simple Chainlink request. So literally any code. We have a couple of questions. So any API is not OCR agnostic, right? And Chainlink Functions is yes, pretty much yes. So this is much decentralized solution and also have much more functionalities than just any API, literally any code. At the moment, for the beta, that's only vanilla JavaScript, but this is beta on a testnet. We're going to expand it pretty soon to multiple languages. Vanilla JavaScript means that for this hackathon, at least, you will not be able to install external libraries like, I don't know, Ether.js or something like that. But again, it's still pretty doable to write JavaScript, because these functions thing come with some predefined functions library, which are extremely easy to use. Okay, so how this thing works for you as a smart contract or software developer, backend developer, the only one thing is important, and that's how to properly send a request. That's it. So in step number one, your smart contract is gonna send your code as a like function argument, and your code, I mean literally JavaScript code, to a decentralized Oracle network or DAWN. And as I said, each DAWN's Oracle node is gonna run the same code in separate serverless environment. And then with step two, the DAWN will aggregate all of these independent computation results, applies a consensus, and returns the final cryptographically verified result to your smart contract. For this workshop, I already mentioned for a couple of times, I'm going to simulate the response. Why is that? Because if there is an error in your JavaScript code or some unhandled error use case, then you will still need to pay some amount of link tokens for computation, because nodes are still going to execute that JavaScript code. But beauty is that you can actually change this JavaScript code, because it's literally a functions, because it's literally like a function argument, solidity function argument. So this is more FYI. Okay, so this is a schema of Chainlink Functions architecture. Okay, we have a couple of questions. Actually, one question that's amazing. Chainlink Functions are going to change everything. Yeah, hopefully it's going to change everything, but you will now need to build some amazing things with it. Okay, so you'll be responsible only for creating this user dApp / smart contract. So this is your smart contract, which again is anything, like whatever you want to build on chain is going to be present there, and there is going to be a call to the Chainlink functions, similar to call to, I don't know, data feeds or VRF, randomness, automation, etc. So your end consumer can be your wallet account, or maybe time-based Chainlink automation if there is something to be automated. I see a question, so I'm going to finish this sentence and answer the question. So after that, or before that, you will need to create a functions subscription. So subscription model is exactly the same as VRF subscription model, automation subscription model, etc. So you're going to create a subscription, fund it with some link, and then you can add multiple consumer contracts to the same subscription. So this is what this Chainlink Functions smart contract billing registry is for. Just for handling subscriptions, you'll need to do that only once, and that's it. I'm not sure for this beta, but there should be like a UI for doing that. If not, it's extremely simplified to call the function method on chain. Okay, couple of questions. Yeah, Edwin says, can you elaborate on Chainlink DAWN governance? Yes. So for at least beta, where we only have like this thing on a testnet, the like consensus mechanism that is being used is median value. So imagine that you have like, for example, 5 nodes, and 5 nodes needs to, I don't know, like divide 2 numbers. Then each of them are going to like via peer-to-peer network report its own value, and then we're going to have like a median value and a consensus. In the same way that if, for example, we have 5 nodes and 3 of them like manage to execute HTTP GET request, for example, and 2 of them like fails to do that, we'll still have a consensus with that. If the callback value from the GET request is the same, we're gonna still have the consensus on that result. This is still in beta once again, so this consensus mechanism is subject to change. But at the moment, for this hackathon at least, it's going to work like I described. Okay, yeah, good question. So when I ask ChatGPT the same question twice, it answers differently. So how do nodes reach consensus if each will get a different ChatGPT response? Well, it's per request based. So your first ask to the ChatGPT is going to be one functions call, and then they're gonna have like the same response. Then with another, it's gonna be another, etc. So that's pretty much the thing. Okay, can you pass a seed? Can you pass a seed to DI so all the oracles represent the same thing with the same prompt? Yes, you can pass whatever you want. I haven't talked about that, but like you can actually pass like API keys, etc., because you're gonna need it, and they are gonna be encrypted. I'm gonna show you how to do that. Which means that they're not going to be stored on chain or they cannot be sniffed. So basically, you can pass whatever you want. Your source code can be whatever you want. You can implement whatever logic you want in it. The node are going to execute it. Okay, we don't have any more questions, so I can continue. This is the second part of the data gigantic diagram, Chainlink Functions architecture. And again, this is the thing that you don't really need to worry about as a smart contract development, but this is how it works under the hood. So request is going through the dawn, then each node is going to execute in the same serverless environment, blah, blah. We already spoke about that. And then it's gonna, as I said, return the callback value to the calling smart contract. So once again, this is how it works under the hood, but as smart contract development, you're only in charge of this tiny part, your smart contract, and the JavaScript code that you want to pass to the functions. Okay, so coming back to the story, what is this JavaScript code? Well, as I said multiple times, it can be anything, literally anything. So you can connect your smart contracts to some, I don't know, weather statistics data and create like dynamic NFTs. You can connect data, as I said, to password protected IoT devices because, as I said, secrets are not stored on chain. They're encrypted, and only dawns can decrypt the encrypted. They're encrypted with the node's public key, and then each node can decrypt it with its own private key. And then after the execution, the secrets are automatically deleted. So extremely safe mechanism. So like you can connect it to password protected IoT devices like smartwatches, do whatever you want, like I don't know, Tesla cars, like Harry did in one of the previous hackathons, etc. Like yeah, connected decentralized database like IPFS to some on-chain, off-chain governance, whatever you want. Fetch any Web3 data, any Web2 data, like connected with AWS, Google Cloud, Facebook, Instagram, whatever. Like we have multiple of like boilerplate code or demo examples, like how to connect Chainlink functions or smart contracts on a blockchain with Instagram and Facebook business pages, with Twilio and Spotify endpoints, with AWS currency managers, etc., etc. So everything is on smart contract GitHub, and I can even provide all of these URLs on my Twitter afterwards if you want to check those examples as well. Yeah, Twitter API, connect with Twitter, do whatever you want, etc. So these are a couple of suggestions, but if you still need inspiration, there's a separate website called Use Chainlink Functions. So at this website, usechainlinkfunctions.com, there are JavaScript code snippets that you can copy paste and use in your projects. The best part is that even you can contribute to this website. So you can open a pull request, provide some JavaScript code that can be used with Chainlink Functions. Someone from the team is going to review the PR code. Go from the PR and eventually merge it, and it's going to appear at use Chainlink Functions website. So actually, I'm gonna use one of the code snippets from this website for today's workshop, and it's written by the legend itself, Patrick Collins. So yeah, let's build. But before that, we have a feedback form for this workshop and all other previous and future workshops and all other things hackathon related. So whenever you have time, scan this QR code and fill it. It means a lot to us. Okay, so I'm gonna remove this thing. We have a question. I made a PR on use Chainlink Functions, but it's not reviewed. Can you please review that? I think we'll see. I think I can't, but I'm gonna double check it. But someone from the team is gonna review it and eventually merge it. So don't worry about it. Just a lot of things is happening to the hackathon. So the thing is that I probably don't have time capacity at the moment, but someone from the engineering is gonna review it. Okay, let's start with the workshop. So I'm gonna actually paste this to the chat. So functions target. So go to this website and clone this repo. So this is like a Hardhat project, which is like a function starter Hardhat starter kit, which is like a boilerplate code for using functions. But the thing is that there is like a bunch of other branches named tutorial-number. So I highly encourage you to check those as well, because there is like multiple tutorials present in the repo. But we are gonna git clone the repo itself now. So I'm gonna present my terminal. Okay, you should be able to see this. And what I'm gonna do is I'm gonna type git clone this thing and hit enter. So this git cloned the repo inside functions starter kit, and now I'm gonna cd into that folder, functions starter kit, and open my code editor of choice. I'm using Visual Studio Code. You can use whatever you want. But basically, I'm gonna open it with this command. This is like a shortcut, which means that I'm gonna open Visual Studio Code in this folder. Dot means in this folder. So you can open it manually, whatever, but git clone the repo and open integrated, not integrated terminal, sorry, your code editor. Okay, I'm gonna stop sharing this thing. Give me a second. Hide sample project links. I'm gonna share it. I don't have it with myself, but I'm gonna share it on Twitter afterwards. So this is my Twitter handle, and I just need to find it, and I'm gonna share all these URLs. Don't worry. Okay, let's now present Visual Studio Code. Give me a couple of seconds. So share screen window, and you should be able to see this. Okay, I'm gonna zoom it like this, zoom it a bit, and yeah, we can start with the workshop. So this is the repo. Okay, we have another question. Can you compare cost of running some code example in Solidity versus Chainlink down? It really depends on the computation you want to perform. Like Solidity can be extremely cheap for some things, but extremely costly for other. While this is kind of, it's a good idea. Maybe I can do some benchmarking, but you should really come with the example, and then we can figure this out. Like exact numbers, like math thing should be like 10 times cheaper via John than the Solidity. But again, you get the point. How can I send different arguments as input by user directly from the contract to user only needs to enter the arguments? I'm gonna show you in 10 minutes. Okay, let's start. So we have a couple of stuff over here, but the first thing actually that we need to do is that we should install this thing. So open integrate terminal and type npm install. Okay, now that we have installed this thing, let's take a look at the repo itself. It has a really nice README, by the way. So let's see if we can maybe do something like this. Preview. Yeah. It does have like a really nice README. We thought with the overview, support networks. Okay, we have Avalanche Fuji testnet as well. Some tutorials, examples, and then steps that I'm gonna execute now during this workshop. Environment, variable management, etc. All of the commands, glossary, etc. So I really suggest you to take a look and read it. It will take 5 to 10 minutes max, but it is an extremely valuable resource besides the official docs, obviously. So cool. So there's two really important files here. Actually three, but two JavaScript files and one Solidity file. So the first file that is extremely important is this functions request config.js. So this is the config thing for your Chainlink Functions project. The second one is the JavaScript code that we are gonna pass as a function argument. I'm gonna create it right now and name it functions request source.js. So create a new file, name it functions request source.js. And finally, the third one is this functions consumer.solidity. So this is a Solidity contract that actually communicates with the Dawn. This is like a boilerplate code. It has functions library here imported. They're going to be part of the npm package once this project is out of the beta. And it has 3 storage variables: latest request ID, latest response, and latest error if there is any errors. So execute request. This is the source code that you're going to pass. Basically, we're not going to touch the Solidity code at all. And fulfill request, this is where you're actually going to have a response. So it's here, and then you're going to actually do something with the response. The code here is extremely dumb, is just populate these storage variables over here, but this is where you're gonna actually perform whatever you want with the callback values. Like execute request, this is like a syntax, literally copy paste it, and that's it. So config we're gonna set in a minute, but first we need a source code. JavaScript source code that we want to pass to the DAO. So I'm gonna again stop sharing my screen. Remind me which branch you're on the main branch. So you don't need to git checkout. Just clone the repo and we're good to go. I can zoom it a bit. Yeah. I'm gonna zoom it, but before that, I'm gonna share my screen. So as I said, this is use chainlinkfunctions.com website. You can add your own example over here. And here is a prompt AI for response. So again, submitted by the legend itself. This code will ask OpenAI for information on chain. And this 31 line of code is everything that we need for this workshop. Okay. So what I'm gonna do now is that I'm gonna hit this button over here or select everything and copy this code inside that functions request source.js file. Okay, so we're just gonna copy this and then we're gonna explain what the code actually does. Okay, so stop sharing my screen. Present Visual Studio Code. Okay, paste it here. Okay, and zoom it a bit. Okay, save it. So what this thing does, it gets prompt as a function argument. It checked for secrets, and there is like and there is an error handling, means that if we haven't set OpenAI key, it's gonna revert. It makes HTTP request, specifically HTTP post request, to this API endpoint. This is the authorization header. This is the text model that it used. This is the official prompt. I'm gonna set temperature to 1, from 0 to 1. So don't forget to do that. Set temperature from 0 to 1. I can wait a bit. And finally, we have max tokens. So max tokens, you can imagine it as a number of words that AI model is going to return to you. Not exact math, but this is basically for you to limit the response size, because OpenAI API is, if I'm not mistaken, pay as you go. So you know, like this is just for you to save you some money. After that, we have API response. We're basically awaiting this promise to be resolved, and we're returning the result as a string. So this function library has built function and code string. So console log is just a JavaScript console log for us to see it in the terminal. It's not gonna be part of the like, it's not gonna be present on chain. Okay, so before we start, I'm gonna stop sharing my screen once again. And then I'm gonna, thank you for the URL. I'm gonna present my screen once again. Sorry about that. So I'm gonna present this. So you need to go to platform.openai.com, account API keys. I'm gonna paste this link over here. Log in with your ChatGPT account or sign up and generate a new API key. Just there will be a button, generate new API key. Okay. Stop sharing here, paste it in the chat. And before we continue, I must say that there is a possibility that you will get error 429, if I'm not mistaken, which is literally too many requests error. You know that due to its popularity, ChatGPT sometimes have the issues that even you cannot use it like from the web-based UI. So the same things applies to the API keys. If you have that problem, you will need to upgrade your API key plan. It is pay as you go. So that means that they don't gonna charge you a lot if you limit the number of tokens, as I have limited it to 7. That means that when you sign up, I think you'll get like $18 of credit or something, which should be more than enough for this example, and which should be enough for hackathon project. After that, we're gonna figure it out, but this is currently the status. Maybe you will not need to upgrade it, but we are gonna literally see. So again, if you have like 429 error, I think too many requests error, there is like extremely high possibility that you'll need to upgrade your API key. So this is more of FYI for you guys. So I have my API key already. So I'm gonna, for the final time, present Visual Studio Code, and that's gonna be it. I'm not gonna do it again and again and again. Okay, so I'm gonna talk a bit now about secrets management. I'm gonna clear this thing and talk about secrets management. So for this example to work, we will need to set 3 values. OpenAI key, API key, obviously, our private key, like wallet private key, whitelisted wallet private key, and RPC URL for a blockchain that we want to be on. So at the moment, Ethereum Sepolia, Polygon Mumbai, or Avalanche Fuji. Usually, what you will do is you will create .env file, paste that as a plain text, write your private keys, etc., and you will make sure that you don't push that to GitHub. We went one step forward, so there is no .env file. We have created from scratch, again, this package, Chainlink env-enc, which means that this package is gonna encrypt your secrets. Okay, it's gonna create a secret GitHub gist for a single response, for a single request. Sorry, and that gist is gonna be pardon me, it's gonna be deleted after the request. It will automatically generate a file called .env.enc. It's not the best practice to push that file to GitHub either, but nothing huge is gonna happen if you accidentally push it, because there will be present encrypted values of your secrets, private key, API key, etc. So to be able to encrypt those, we will first need to set up the password. So make sure you remember that password. And to set it up, the command is present in the README actually as well. So README is extremely valuable resource for this thing. So the command is npx env enc set pw. Okay, once again, npx env -enc space set -pw, set password, and hit enter. So again, enter the password. Input will be hidden, so I'm gonna enter some password and hit enter. This is an extremely bad password, by the way, but I literally typed test just for this demo. So I'm gonna copy paste this thing to the chat as well, so you can copy paste it. So type this. We have an interesting question. Does env-enc have a YubiKey integration? Like 99% no. Actually, I think no. But this is good. This is good suggestion. Maybe engineering team can expand it. But at the moment, I don't think so. I got the error 429. Yeah. So I spoke about error 429. That means that you will probably need to upgrade your OpenAI API key to a paid plan. Unfortunately, like it's gonna be extremely like you'll spend like $5 max for the hackathon itself, but you will need to connect your credit card to do that. Sorry, that's like just OpenAI ChatGPT thing. Nothing we can really do about it, or just wait for like less traffic on ChatGPT. It's extremely popular. So yeah. Okay, so we set the password And now our next command will be npx env-enc set. So I'm going to type that npx env-enc set. Okay. So now for each variable name, I'm going to enter the value itself. So we're gonna go really slowly with this. So first, this is the command for you to copy paste this. And we will need to set 3 values. So value number 1 is RPC URL. So I'm gonna use Polygon Mumbai, but like I'll set Polygon Mumbai RPC URL, or you can set these 2 as well. Okay. So how I'm gonna set Polygon Mumbai RPC URL? I'm gonna, give me a second, copy the name of the secret variable itself. Polygon Mumbai RPC URL. I'm gonna hit enter. Now I'm gonna enter the variable value. So I'm gonna now enter that endpoint, which can be which you can get from Infura, Alchemy, all of other these node as a service, or if you're running your own Polygon Mumbai node, then your own node. But here you're gonna enter the whole, for example, if you're using Alchemy, the whole Alchemy URL with the key itself. So I'm gonna now copy paste this thing from my nodes. You unfortunately won't be able to see it, but this is like Alchemy endpoint for like Alchemy RPC URL that I'm gonna use for Polygon Mumbai, and I'm gonna hit enter. And now it says, would you like to set another variable? If yes, again, repeat the process. So the second variable that I want to set is private key. So this is my wallet private key that is whitelisted for the usage of Chainlink Functions. So private key, this is the name of the secrets variable. So let's say, so copy paste private key, or I can actually type it. Private key, another variable, hit enter. Please enter the variable value. So right now, I'm gonna copy paste my whitelisted wallet private key. Okay, I'm gonna grab it from my notes, paste it here, and hit enter. Again, would you like to add another value? Yes. We need to add OpenAI API key. And let's see where it is. Oh, give me 20 seconds. Yeah, we can actually do something like this. OpenAI API key. Okay, so we are gonna set this value. Okay. First, paste it into the chat. Okay, this is the naming I used. So OpenAI API key. This is the variable name. Hit enter. Enter or copy the API key itself. I'm copying it right now, and hit enter. Would you like to add another variable? No. So to finish, I need to press enter. And that's it. I've successfully set all of my secret variables. Do we have any questions so far? Yeah, another thing that I mentioned, the new .env.enc, so env encrypted file is going to be generated. And this is, put this down, put this aside. This is the content of .env.encrypted file. So this is my RPC-URL, my private key, and my OpenAI API key, but they are encrypted. These are not the actual values. These are encrypted values of the secrets that I provided. So even if you push that to the GitHub, only with your password, this can be decrypted. Okay. Do we have any questions? If someone is running a node, what prevents him from extracting the encrypted secret key and use it on its own? This is currently work in progress. So for the beta, only Chainlink nodes are being run. So we don't have that concern at the moment. But again, for the production, engineering team is currently working on a system that is going to prevent this from happening. Obviously, this is a big concern. Do we need all three of these RPC URLs? No, only one. For this workshop, I'm going to use Polygon Mumbai, but I pasted for you to know that there is Sepolia and Avalanche available, and this is the respectable secrets names. So we're going to use Polygon Mumbai. Actually, we need this RPC URL just for a thing to work. As I said, I'm going to just simulate this. I'm not going to deploy it to Mumbai. Is there a script available that we can run to ensure that the keys have been correctly? I don't think so. I can create one for you, but what you can do is that you can type npx env enc view this command, and with this command you can validate that you have set them correctly. So this is gonna decrypt them and display them in your terminal. So I'm not gonna do it at my end because you're gonna see my secrets, but this is the way. I mean, they're dummy secrets, by the way. I created a new keys, new ones, everything from scratch. So no worries about that. But yeah, so this is how you're gonna view it. No worry, TV, no worry. Which algorithm is used? I don't know, but we can check it later. There's like a source code available at the package.json file or like at GitHub. I haven't checked it. Sorry. I should know that actually, but we can check it, and yeah, I can maybe answer this on Twitter. Okay, now the fun part. Let's combine these secrets with the config that can execute the source code we copy pasted from Patrick. Good one. Okay, but try it. But these are all dummy values, by the way, so there is no money there. Okay. Yeah. So you can see the code. Excellent. So I'm gonna split this on the right so you can follow along better. No, at the moment, no. Okay, so we have this config. Couple of stuff. So we have a location which can be inline remote for secrets where you can store them. We have languages that you can write code for at the moment. Again, only JavaScript, vanilla JavaScript is supported. There are a couple of return types. So these are the types that can Chainlink functions can return to the calling smart contract. So inside that fulfill request function in Solidity, you should actually be aware of the data type that your response is gonna be. So you can send unsigned integer, signed integers like numbers, strings, and buffer is basically for bytes. So bytes can be anything. Like you can ABI encoded on the JavaScript side and ABI decoded on a Solidity side. So it can be like address, array of addresses, structs, mappings, array of structs, whatever. Like this is extremely powerful. Whatever like bytes value can be in Solidity. Okay. Then we have this request config that we need to set up. So first of all, location of your source code. Again, inline or remote. We are in beta, so only inline is currently supported, but can be remote as well. Then code language. Again, JavaScript. Okay, nothing that we can actually set here, so we're gonna skip these two. Third one, source code. So where is our source code? So our source code is actually inside functions request source.js, which is present at the root of this repository. So what you can see here, that there is like calculation example and API request example. So these examples is like tutorial examples, boilerplate code. You can actually check it out, try it, but I skipped it and go straight to the ChatGPT thing. So what I need to do here is that I actually need to type functions request source. That's it. Like this is the source code, like JavaScript source code. This one. Then we have secrets. Okay. So secrets can be accessed within source code. Why do we need secrets? Like because we maybe want to provide some secret data to the calling JavaScript code. So I'm gonna split this to the right, and here you can see that we are using only you can access secrets object, this one, with secrets keyword, and then this example has OpenAI key. So what I need to do is that I actually need to set this value here. So I'm gonna change. So OpenAI key is OpenAI API key that I encrypted using env-enc library. Okay, so this literally means that, okay, I have a typo here, that from secrets object from OpenAI key, it's gonna decrypt it and use only this variable inside for a code execution. Okay. Then we said we have HTTP GET request, which has this prompt, and where this prompt comes from here. It's the first argument. So okay, per node secrets, nothing for this workshop. Basically, it's assigned to each DOM member. So which means that if you have like four nodes, you can actually specify per node secrets. This is gonna and then you'll have like some code logic in your JavaScript code, which so this is basically for you to prevent to hit like, I don't know, four. So let's say that you have four nodes and you want to send an email after some computation. You don't want to send 4 emails, you want to send only 1 email. With per node secrets, you will have some kind of flag as another secret, and then you will have like a actual JavaScript logic for handling that secret. So if node is aware of that flag value, then it's gonna send the email, otherwise not. So this is why per node secrets exist. Wallet private key, just get the private key from the env, and yeah, arguments. So these are the arguments that you can provide to the JavaScript code, like a function argument. It needs to be a string array. So these are a couple examples and dummy ones. Here is the actual prompt that we want to send. So if you have any examples of or any recommendations for what should we ask ChatGPT for, please write into the chat. I'm gonna wait for a minute or two, and then we can continue with the workshop. Until then, I can answer some questions. So, okay, can we? Can we use functions without env, enc? No. You will need to at least encrypt vault private key and RPC URL. Otherwise, it's gonna fail. And this is basically the reason why. So thanks, DP, for clarifying that. What was the temperature stuff in data HTTP request? Good question. So this is from the ChatGPT docs, actually OpenAI docs. So I'm just gonna quickly go there. So to give you the exact answer, give me 20 seconds max, basically. Okay. Temperature. Okay, so temperature can be 0 to 1. 0 is minimum, 1 is maximum. The higher temperature, the more creative is the response, while the lower temperature, the more predictable is the response. This is basically TLDR for the temperature. So for the return type, if you're making our own custom version, we just make a conversion of that argument. What should be its solidity? Yes, that's correct. The only thing we can, yes, basically. Okay, create a character sheet for a Dungeons and Dragons Dragonborn wizard named Sleuth. Okay. And change the name to Andre. That was clever. Okay. Asking because I want to use it in Foundry. Yeah. I'm not sure about the workaround for Foundry because this is JavaScript only, but maybe we can hack something and continue the conversation on Twitter. And temperature, yeah, thank you. I haven't seen these comments, sorry, so you save me some time from Google. Okay. So we have only one suggestion about Dungeons and Dragons character, but maybe we can do something similar because we want to limit to a single line. Maybe. Okay, let's see something like this. Please give me a name of Chainlink Dungeons and Dragon character in one line, maybe. Chainlink Marine Dungeons and Dragon character in one line. Let's try with that. I don't know. If you have something more exciting, we can try that. And final thing is that we need to specify the return type. So we are not expecting number. We are now expecting string. So we want this thing, JavaScript thing, to send the string to a calling smart contract, which is actually written here. So encode string. Okay, the moment of truth will be to simulate this thing. So to simulate response, you're gonna type npx hardhat functions simulate, if I recall the command correct, and hit enter. So it compiled a bunch of contracts because I haven't compiled it yet for the first time. And now executing a code. And yeah, we got the name Varana the Sioux, if I pronounce that correctly. So this is the Chainlink Dungeons and Dragons character name. Let's put it here into the chat. If we want to ask something else, we can try that. Let's see. Are the arguments passed in the const request config fixed? How one can pass multiple secrets? Yeah, you can just have another argument over here, like another secret type whatever, and then inside the JavaScript code you will have secrets, another secret, and that's pretty much it. I'm gonna delete this. Okay, do we have more questions? Okay. If not, that will be it for today's workshop. Now is the time for Q&A session. We are right on time, exactly 1 hour, so that's cool. If we don't have a question, maybe we can ask ChatGPT something else. Maybe we can create a superhero name. I don't know, for Chainlink character to see the actual name. Maybe, I don't know. Oh yeah, what was the command you just run? Okay, give me 20 seconds to share my screens once again. Window functions requests. Yeah, sorry, Visual Studio Code. You should be able to see this. So the command was clear npx hardhat functions simulate. Okay. So I'm gonna put another prompt here to create a superhero name for a Chainlink Marine in one sentence. And while this is running, I'm gonna copy paste this to the chat. This is the command, okay. And Chainlink Marine, that was really dumb name. I think I got like Aqualink or something while I was testing this thing, but nevertheless, okay, we have an error, invalid input. So actually we're again passing the source, secrets and arguments. Can there be something done which requires only arguments and we get the result? Well, the thing is that once you set the secrets, that's pretty much it, because you will need to handle them into the source code, which you need to finalize like we did, like Patrick actually did. We literally copy pasted from usechainlinkfunctions.com. So again, after I set up secrets, like that part was done. So I'm just changing the prompts, which is like a function argument, like first element in args array. So like pretty much after you set everything up, you'll just need to pass different arguments if you want, of course. So yeah. Okay, so invalid input. Tippy, have you changed the expected value type to be string instead of uint 256? Maybe that's the error. We need to encode string. Is there an equivalent of gas limit on Dawn to prevent running infinite loops? Yes. At the moment, so the maximum gas limit for you to send from Solidity to the Dawn should be 3000, this value. So this should be like a gas limit to prevent infinite loops. Can talk a little bit about limitation of Chainlink functions for now. Yeah, first obvious limitation is that you'll need to sign up for beta and then wait for 24 hours. Until then, you can just simulate a thing like I did. Second one, it's present only on testnets, so you cannot go to mainnet. And yeah, we'll need to find, as your colleague mentioned, we'll need to find like a workaround for Foundry. I haven't tested this thing with Foundry yet, but there should be like a workaround with this library. But again, it's more like JavaScript opinion at the moment. Other than that, I don't see any downsides at the moment. You have a return type string doing it? Actually, no. Actually, no, but I can maybe push this thing to the GitHub and then you can literally run it at your end and compare it. I don't know. Everything that I did should be enough. So change secrets, arguments, source code location, expected string, and copy paste Solidity. Again, copy paste JavaScript stuff. Solidity is already there. No, there's not a limit. I manually set it up with number of tokens set to 7, which in theory means like 7 words. Like in practice, actually, 7 words. In theory is different, and that's why I specified that answer should be in one line. This is just for you to save some costs on using API, OpenAI API, because it is pay as you go. You can change it by setting the higher number for number of tokens. But if I'm not mistaken, you actually need to set number of tokens per OpenAI documentation. Maybe I didn't change. Yeah, try that. Like you'll need to paste the prompt in as an argument, as a string. Getting an error, yeah, that means that that this is literally too many requests error, so too many requests to the OpenAI API endpoint, which means that unfortunately you will probably need to upgrade your OpenAI API key to be the paid one, and you will get some credits, like I think $18 or $5 or something, which should be enough for hackathon. But yeah, you will need to connect your credit card there, unfortunately. When do you plan to make Chainlink Functions available on mainnet? I have no idea. Like soon, but I don't know. I don't know. I don't know when exactly, but I guess pretty soon. I don't know. Patrick had like an interesting sentence somewhere on Twitter, like sooner than you think, but not soon as you would like, or something like that. He wrote that better. But yeah, if we don't have any further questions, that will be it for this workshop. Thank you again for attending the workshop. Once again, yeah, let's add this to a screen. Sign up this feedback form. It's a short type form, which will help us make this workshop and general hackathon experience even better. Yeah, sooner than you think, but later than you expect. Yeah, this is the actual sentence from Patrick. Thank you guys for attending this workshop. Thank you. I hope this was a valuable usage of your time. I hope you learned something new. And don't forget to sign up for the AI track. And I'm cheering for you. I hope that you're going to build some amazing stuff during hackathon. Thank you and have a good one. Bye-bye.